Asteroids are remnants of the early solar system. They are leftover pieces as the solar system was forming, and around the same time that life was forming on the early Earth or other bodies. And so the same chemistry that was happening that could influence the origin of life is preserved on these relics of the ancient solar system.
You can't have life on a planet unless you have a biosphere, which means you have to have all the appropriate carbon, oxygen, hydrogen, nitrogen, all the kinds of elements you need for life. And so if those aren't delivered, then you're not going to get anywhere. Obviously, OSIRIS-REx is visiting one of these objects, and it's not just visiting any old asteroid, it's visiting a really appropriate one for these questions about astrobiology, because it's a class of asteroid which we believe is associated with a type of meteorite called carbonaceous chondrites, which are amongst the most richest meteorites in terms of their carbon abundance and also their molecular complexity. So OSIRIS-REx can then attack these various issues in several ways. Of course, one is we have some instruments on board the spacecraft which give us a global look at the asteroid.
On October 20th of this year, OSIRIS-REx will attempt its first touch-and-go, or TAG event. This will be NASA's first ever attempt to sample an asteroid in space, with the hopes of returning it to Earth.
So for fun, here is a Lego version of the OSIRIS-REx spacecraft. It has articulated solar arrays, a science deck, a sample return canister, and this 3-meter long arm. And the end of this is sort of like an old car air filter, but of course bespoke design for this mission and for this asteroid, to collect a sample of material and bring it back to Earth by touching the surface of the asteroid, collecting at least 60 grams, as much as 2 kilograms of material, go out and measure the mass of the material, and then stow it in the sample return canister, bring it back to Earth.
So when we get these samples back, we're going to be interested in these aspects of the samples. What are their bulk elemental abundances? And also, what kinds of specific compounds are present? And what can they tell us about how they formed and where they formed and when they formed? And in particular, could any of these molecules have played a role in helping get life started on the Earth or any other place? One of the huge advantages of a sample return mission is that when you get the sample back to the Earth, you've effectively added all the world's analytical instruments to the payload of your spacecraft. Okay, so you can afford to do analyses of the return samples that would never happen on the spacecraft. Some of the instruments we'll use to study the return samples are not just bigger than the spacecraft, they're bigger than the launch pad the spacecraft left from. That will allow us to take a portion of the asteroid and really dig deep into what's there. And then because we have the global data from the in situ instruments, we can then put all that information in the context of the asteroid as a whole.
60 grams of sample is a bounty. If you look at, say, the Stardust mission, which brought back maybe a milligram of material from Comet Field 2, that revolutionized our understanding of solar system dynamics and solar system formation. So 60 grams, which is our baseline, is a huge bounty for the cosmic chemistry and astrology. The most exciting aspect of this mission is that when we collect the sample, 75% of it is archived for future generations. So samples will be studied by people not yet born, using techniques not yet invented to answer questions not yet asked. People who are in school now can make life choices to enable them to study the samples and ask questions that we just can't think of today. We just don't have the ability to analyze.
It's just hard to overstate the power, the scientific power you get out of this. This is why missions like OSIRIS-REx are just so powerful, is because a mission gives you a legacy that just extends on into the future and never really ends.
Visit asteroidmission.org to learn more about the OSIRIS-REx mission and watch the upcoming TAG event live.